So today we are going to be looking at measurement in physics, how we carry out measurement, and the different tools that we can use to measure. Now, first things that we're supposed to know is that in physics, when you are measuring values, you must consider the accuracy. So accuracy is just the closeness of your own answer to the actual value. So let's assume that the length of a stick is 20 centimeter and you are asked to measure it, and you measure it as 19.9 centimeters. It means you are accurate. Even if you measure it as 20.1 centimeters, it means you are still accurate. Why? Because these two are closer to the actual answer. But the length is 20 centimeter and you went and measure it to be 30 centimeter, you are not accurate at all, because 30 is not even close to 20. So that is what you mean by the accuracy of a value. So since we are concerned with accuracy, that means that we must use instruments that are going to give us a high percentage of accuracy. So it is important that we use instruments that will ensure this. Now, accuracy of instruments must be noted. So you must know any instrument that you want to use, and you must know the accuracy of that particular instrument. Now, this is shown in the significant figures. So how you record values in physics, we call them significant figures. Now, these significant figures are going to show us how correct your answers are. They are going to show us how correct your answers are going to be. Now, when we move forward, we are going to explain how this works. Now, when giving measurements in physics, the uncertainty is also important in some cases. So there are some cases that whenever you want to give us measurements, you must give us the uncertainty of your answer. You must give us the uncertainty of your answer. That's why if you record a value for a meter rule, let's say a meter rule, you measure a length to be 20.1 centimeter, you are now going to tell us that this is plus or minus 0. Let's say plus or minus 0.01 centimeter. This is going to be the uncertainty of this particular measurement. Now, why are you going to say this is okay? The uncertainty of a meter rule is actually 0.05. Is 0.05. Now, the uncertainty is just the half of the smallest division that you have. It is the half of the smallest division that you have for a meter rule. Please don't make mistake. That's only the case for a meter rule. If you want to know the uncertainty of a meter rule, this is just the smallest, the half of the smallest division. Let's say you have something like this, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1 centimeter, 2 centimeter. Now, let's say you now measure a stick that is this long. How will you record the value of this stick? How will you record the length of the stick? Let's say the stick reached this particular point. Now, what you are going to record is it's above 1. So you say 1. Now, point, because each of this one is just 0.1. So this is 0.1, 0.2, 0.3. Now, it's between, now that means you are sure that it is above 3. So you say 1.3. But you are not sure whether it's reach 4 or it does not reach 4. So let's just, that means that you can now estimate what is going to be 1.3. So between 1.3 and 1.4. So what's between 1.3 and 1.4? That's 1.35. But this 5, are you sure of it? No, you are not sure. So that's why you are going to say this is plus or minus 0.05. So that means that the value might actually be less than this value that you are recording. That means that it can be 1.3. That's if you remove this 0.05. Or it can also be 1.4. That's if you add this 0.05. That means that the value is just between 1.3 and 1.4. But you are not sure of what the actual value is. But you are sure of this one and you are sure of this 3. So that's why if you want to record this value in physics, you know, we said we are going to be recording in significant figures. What you are going to write for us is just 1.3. You write only those ones that you are sure of, which are this first one and this 3. So your value is just 1.3. Those are what? The significant figures. Now, so significant figures include the first non-zero digits together with the trailing zeros. what we mean by this is that, let's say you have a value 0.015000. If you want to record this value, you won't go and say because of uncertainty, you now record the value as 0.0. This 0.0 is useless. You are not measuring anything. 0.00 here is also useless because you are not measuring anything yet. But once you start having number, that's when you start having significant figure. So that means it should be 0.001. Then you can now continue, or you can stop anywhere you want, depending on what they ask you to do. But you must make sure that you start from where you keep writing the zeros until you get to the first number, and that is going to give you your what, your significant figure. So it must include the first non-zero. This is the first non-zero. So you start from the beginning, 0.00 till you get to the first non-zero. Then that's when you can now stop. But once you don't get to the first non-zero, you can't stop. Even if there are 100 zeros, that's why you keep writing 0.0000 until you reach 100 zeros. Then when you now see the first number, you now write it. So that's what we mean by significant figure. And if there are those zeros after it, you might include them if you like, and if you like, don't include them. Now, so let's look at the measurement of length. How can we measure length? So we only need to know about meter rule, vernier caliper, and micrometer screw gauge. Those are the three important ones that we must know about for measurement of length. Now let's look at meter rule. Now for a meter rule, this is what we have for a meter rule. 1 2 3 4 5 6 7 8 9 10. This is 1 1 2 3 4 5 6 7 8 9 10. This is 2. Now on the meter rule, you notice that here they will write millimeter, and here they will write centimeter. What they are trying to tell you is that if you are counting these ones, you are counting millimeter, but if you are counting the upper ones, you are counting in centimeter. That's what it means. So let's assume that we have an object that reached this particular point. So if you want to count, you can say 1 2 3 4 5 6 7 8 9 10. That's 10 millimeters, which is the same thing as 1 centimeter. That's if you are counting it up. So you just say 10 millimeters, 11 millimeters, 12 millimeters, 13 millimeters, about 13 millimeters. So you just say it is 13 millimeters. Now 13 millimeters is what? Is actually 1.3 centimeter. Is it not? Just divide this by 10. That's how you convert from millimeters to centimeter, because from here you can see that 10 millimeters make 1 centimeter. 10 millimeters make 1 centimeter. Now another thing that you're supposed to know about meter rule is that you're supposed to know the smallest graduation. The smallest graduation is just the smallest one that you have, which is just 1 millimeter. So the smallest graduation is 1 millimeter. Now you need to know the value of that smallest graduation. Now how do you get the value? Just divide both sides by 10 here. This we cancel. You have 1 millimeter, which is the smallest, is what? 0.1 centimeter. Now this 0.1 centimeter is now the accuracy of a meter rule. That means that whenever you are using a meter rule to record, you are always sure of all the digits, including the first digit after the decimal. But after that first digit, you are not sure again. Just take a look at an object that is this long. Let's say the object stop here. If you want to record this value, this is 1 centimeter, 1.1, 1.2, 1.3, 1.4. So you say 1.4. But you are not sure whether it gets to 1.5. So that's now where the problem is. So you can just say it's around the middle of 1.4 and 1.5. So let's say 1.45. Or if you like, let's say 1.49, because it's very close to 1.5. You can say it's 1.49. But you now tell us that plus or minus 0.01. Now look at this 0.01. 0.01, sorry, 0.05. Because the middle, the smallest division that you have in the meter rule is actually 1, right? Now you now divide it into 2. So if you're having 1 millimeter, divide 1 millimeter into 2, you are going to have 0.5 millimeters. Now this is now that 0.5 millimeter. But don't forget that we are writing it in centimeter. That's why you have to divide it by 10 again to give us 0.05 centimeters. So now look at this. What this means is that this 5, you are removing it from this last one, because look at, just count the number of digits. The first digit, there is nothing there. That means you are sure of that one. But this last digit, that's where it is. So it corresponds with this last digit too. That means that you are not sure of this 9. You are not sure of this 9. So this 9 is actually the uncertainty. But if you want to record this value, you are going to record 1.4, because 1.4 is the significant figure, because you are sure of 1 and you are sure of 4. Is this 9 that you are not sure of? But if you want to record it with the uncertainty, that's when you now include that one that you are not sure of. But in that case, you have to do this plus or minus and put the uncertainty, the degree of uncertainty, which is just half of the smallest division for a meter rule. Don't forget, that's only for meter rule. Now, another thing about meter rule is that whenever you are taking values, you must always read vertically down. So that means that if you have a meter rule this way and you want to take values, don't look at it like this. You are going to be wrong. Or you come and position your eye here, then you now look at it this way, you'll be wrong. You don't look at it from the side, you look at it from the top. So you look at it this way, then you take the value. You take that value from the top, because that's when you can be sure that you are taking the actual value. Now, if you take your value from the side, we call it, you are going to have an error, and that error we call it parallax error. Parallax error. So the error due to your own position, your movement, that's what we call what? The parallax error. So that's what we have for meter rule. Now, what about vernier caliper? Now, for a vernier caliper is even more accurate than a meter rule. Now, you know, a meter rule, the accuracy is 0.1 centimeter. That means that you are sure of the first digit after the, you are sure of all digits, including the first digit after the decimal. But any digit after that first digit, you are not sure again. But for vernier caliper, the accuracy is 0.01 centimeter. That means that you are sure of all digits, including the first digit and the second digit after the decimal. But after that, that's when you can now start having uncertainty. That's when you can now start having uncertainty. Now, a vernier caliper has 2 scales. It has 2 scales. Now, before we talk about the scale, you should know that you can use to measure the thickness of a ruler. Now, those values that are small, that you won't even be able to use ruler to measure, that ruler will not give you a very accurate answer. Not that you can't use ruler to measure them, but it won't be accurate. So, thickness of a ruler, internal and external diameters of a tube, we use what? Vernier calipers. These are questions that come out in JAMB. They will give you a vernier caliper, ask you to take the reading. They will give you a micrometer screw gauge, ask you to take the reading. They will give you the diagrams and now ask you what are the values. Now, so a micrometer screw gauge has 2 scales, the main scale and the vernier scale. Now, for the main scale, it is in centimeters, just like the bigger division of the meter rule. That is also in centimeter. Now, the vernier scale is in millimeters. So the vernier scale of vernier caliper is in millimeters. Now, the vernier scale is also divided into 10 parts. This is actually what makes a vernier caliper to be more accurate. You already know that the vernier scale is in millimeter, so that means the smallest is 1 millimeter, just like the smallest in meter rule also. Don't forget that the smallest in meter rule is also 1 millimeter. Now, when you now get to vernier scale, this 1 millimeter, they still now give you opportunity of dividing it into 10. So by the time you divide it into 10, this will be what? 0.1 millimeters, and this is the accuracy. 0.1 millimeters. If you convert 0.1 millimeters to centimeter, how do you convert? Just divide it by 10. That will be 0.01 centimeter. So this is the accuracy of a vernier caliper in centimeter, while if it is in millimeter, this is the value in millimeters. So that means that any value that you record for a vernier caliper, you will be sure of all the digits, including the first and the second digit after decimal. But anything after that, you are no longer sure. For example, if you are given a value of 2.52 to record, if you are recording this with a meter rule, you already know that meter rule is 0.1 centimeter. So that means that if it's meter rule, what you're supposed to record is 2.5 centimeter, because you are only sure of this one. You are not sure of this. If you want to record everything for meter rule, it must be 2.52. Then you include your uncertainty plus or minus 0.05 centimeter. because this 0.05 is constant for a meter rule, so you must add it to it to show them that you are not sure of these last two. But if it is for vernier caliper, you are sure of these last two, so you should write everything that you are sure of. So if you want to write everything that you are sure of, that means that you are going to write what? Your 2.52 centimeter completely for a vernier caliper. But for a meter rule, you only stop here. How will you even get this 0.2? You are not sure of it, so you can't get it in a meter rule. And if you get it in a meter rule, you must include plus or minus something to show them that you are not sure of that. You just put it there for putting sake. Now, so you should know that a vernier caliper is more accurate because you are even sure of the second digit after the decimal. Now, what about the last one, which is a micrometer screw gauge? Now, for a micrometer screw gauge, it can be used to measure smaller values that even vernier caliper cannot measure those values. For example, the diameter of a wire, all those wires, very thin wire, you can use micrometer screw gauge to measure the diameter. The diameter of a small ball, if you have a very small ball, you can use the micrometer screw gauge to know the value of the diameter. You can even measure the thickness of a piece of paper. Look at how thin a piece of paper is, and micrometer screw gauge, you still be able to measure the thickness of that paper because it is very accurate. Now, the micrometer screw gauge also has two scales, the main scale and the vernier scale. So it has two scales also, the main and the vernier scale. Now, the main scale is in millimeters. Now look at that. For a micrometer screw gauge, the main scale is in millimeters. So that means the main scale is even smaller. That's why it can even take and measure smaller values accurately. The main scale is in millimeters, while the vernier scale is divided into 50 equal parts. Look at that. For a vernier caliper, don't forget that the main scale is in centimeter, the vernier scale is in millimeter, then they now divide it into 10. So the more the number of divisions, the more accurate it becomes. So, but for this one, they have divided it into 50. Just imagine, they divide it into 50. Now, they now say that 50 division is the same thing as 0.5 millimeters. So that means that 0.5 millimeter, they divide it into 50 equal parts. What will be the answer that you are going to get? You get 0.01 millimeter. So that means that each of these division is what? 0.01 millimeter. And that's the accuracy. Now, if you convert it to centimeter, how do you convert to centimeter? You divide it by 10. That will give us 0.001 centimeters. Now, look at it. Is it not more accurate? For meter rule, it is 0.1 centimeter. For vernier caliper, it is 0.01 centimeter. But for meter rule, it is now for micrometer screw gauge, it's now 0.001. Which means that if you have a value like 2.523, if you want to, or 5234, if you want to record it with a meter rule, what are you going to write? You write 2.5. This is the significant figure. You write only the significant figures. What if you want to record it with a vernier caliper? You are going to write 2.52 because you are sure of the first and the second digit after decimal. Now, even if it is 22, that's how you write it. You write 22.5, you write 22.52. How do you record for a micrometer screw gauge? It will be what? 22.523, because you can write up to the third one. So that means that it's after the third one, this fourth one, that you are not sure of in a micrometer screw gauge. You are sure of the remaining three. Now, if someone just give you these three values, which one will you say is more accurate? Is this, because this one contains more numbers, so automatically it's going to be closer to the actual answer, right? So that's it for a micrometer screw gauge. Now, what I'm going to do is I'm going to try to record another video that we are going to see how we can take measurements on the micrometer screw gauge and also on the vernier caliper, because it is very important. They always ask this question in JAMB. They will give you the diagram of a micrometer screw gauge, ask you to take the value. They will give you the diagram of a vernier caliper, ask you to take the value. They ask you they just ask you which of the following can be used to measure accurately the diameter of a small bulb. What we use? You use micrometer screw gauge because it's the most accurate one. But if they ask you which of the following can be used to measure accurately the internal diameter of a tube, what's the answer? You can't use micrometer screw gauge, because although micrometer screw gauge is more accurate, but in that case you can't use it because the diameter of a tube, the internal diameter of a tube, this internal diameter, you must use something that can enter the tube, and micrometer screw gauge cannot enter any object. You will later see when we do how we can use it. When you see how it look like, you see that you can't put micrometer screw gauge inside anything. You can only put something inside micrometer screw gauge. So it's not possible for you to use micrometer screw gauge in this case. It's either you use the meter rule or you use the vernier caliper. Which one will you use? You use vernier caliper. Why? Because vernier caliper is more accurate and is the one that is the most perfect for that kind of situation. So this is where we are going to stop. So we must make sure we know the accuracy of each of these apparatus, both in centimeter and in millimeter. You know, if you want to convert to millimeter, just be multiplying it by 10. This will be 1 millimeter. This will be 0.1 millimeter. This will be 0.01 millimeter. That's if it is in millimeter. But if it's in centimeter, these are the values in centimeter. Know the smallest value. Know what you call accuracy. Accuracy is the closeness of your value to the actual value. Know what you call the uncertainty. The uncertainty is just the digit that you are not sure of what it is. So that's where we are going to stop.